Alright, time for another draftphysics.com, debatephysics.com also, video presentation. So, yes, the push-a-verse verses, okay, small little verses, Jason Kendall. So I watched a few of his videos, really not bad, but it's just standard stuff, and there's huge contradictions in the statements, and so I just thought I'd play some of those. And, he's basically a little bit of a rocket scientist, frankly. It's astronomy mostly, but he does have as his channel icon a little rocket, that he's playing with. And so, just little questions. It'd be nice if physicists would answer the small little questions, like what landed the lunar module on the moon? Kinetic energy or momentum? I mean, what was the calculation for the thrust? Was the thrust calculated as kinetic energy and that decide how long you left the thruster on? Or is it just mass and velocity of the particles and that makes the spaceship move? And so that just relates also to the thrust launching the rocket. What's the reality? Momentum or kinetic energy? Which one makes the rocket go in the equal and opposite reaction? Is there an equal and opposite amount of kinetic energy, or is there an equal and opposite amount of momentum? And it'd be just nice for these guys to answer the question and resolve the issue instead of pretending both theories are viable in some way. And frankly, it's pretending. Because how many times do you have to go over this? These are not difficult questions. And they just take it as some personal affront. You're some kind of science denier if you disagree with their theory, and their theory has 4 million holes in it, and it's just, it's just obnoxious that they talk as if this is all well-established truth. I think he actually says something about the double slit experiment proving light is a wave, over and over. Anyway, I'm complaining, and I really don't. There's just no way to know what you're going to get in return. So, we'll see what happens. See if this guy can participate in a little bit of back and forth regarding what physics claims and the scrutiny of somebody who might say, well, doesn't this statement by physics and then this statement by physics, don't these two statements contradict each other? Conservation of energy, and then you have this idea that the gravity creates a huge amount of pressure in objects, right? Especially the big ones like suns, and they produce a huge amount of energy out. I mean, in Kelvin, the Earth is pretty hot. I mean, anything above zero is hot. Anything that's producing anything is something. So you're saying you're creating a bunch of, let's say the Earth is excreting 200 Kelvin in radiation per, that's the tricky part, per what? Well, anyway, it's that's a lot of heat if it's per foot or per inch, of surface, whatever the amount would be. That's a lot of heat that Earth is excreting into the universe, and it's all for free because there's no mechanism to put the heat back into the gravity that caused the heat. So where's the conservation of energy there? It's totally broken. Could you explain, please? Now, maybe the sun, you say it gets hotter than it would be. So if just gravity existed, how hot would the sun be? That would be a question. And then if you do this thermonuclear thing where you're saying pushing hydrogen into a helium nucleus, right? So you're taking hydrogen's bigger than helium because hydrogen floats even faster. It's even more buoyant than helium. And you're saying, well, if I take big things and I smush them, I can make more energy. That doesn't even sound right. Breaking atoms makes sense. Energy, you're releasing, you're breaking something that has energy, compression in it. It was made through compression, and now you can extract some energy. But extracting energy, compressing things, well, that sounds, like it doesn't sound right. It sounds like you're going to have to put a lot of energy in, and all you can get back out is the same amount of energy you put in. You want somebody else to compress the spring, and then you get the free energy from somebody else doing the work. You don't want to do the compressing of the spring and then say, look at all the energy I made when the spring expands, right? Okay, that's not too challenging. Come on. These questions really should be answerable. And it's just sort of annoying that you can't get them answered. I mean, the whole gun thing. Why would Newton write a third law if kinetic energy was a thing? 2,000 joules goes that way, 2 joules goes that way. Where's the third law have anything to do with a gun? Yeah, no. Anyway, all right, so we'll start playing the video. And I'm just trying to, it's hard to be nice after all these years of doing this, and you just know what's coming, and you're just saying, okay, let me just try to say, okay, is there some human being who can just have a channel where they talk about physics and nothing else matters? They're making money doing this, none of that stuff matters. Just the physics, just the science, just the arguments, just the evidence. That's all that matters. Can somebody please do that? So I didn't notice he has a bow tie. Yeah. So he filmed these. He was a teacher for years, but this is, I think, obviously a green screen. So he's just reenacting his previous life as a teacher. Performance art. But anyway, it's perfectly valid. He did put in the time and all that crap, so nothing to say there. I think he looks better without the beard mustache, but whatever, that's just my opinion. Anyway, yes, I want to hit the play button, and then we'll play some of it, and I'll just point out, oh, come on. You can't really say that, can you? And aren't there better explanations? That's what I'm going to do. All right, I probably should say real quick, okay, there's a simulation video. Somewhere around here, the charge simulation. Okay, so on the draftphysics.com website, there's a simulation video that really explains charge in the simplest manner possible. I mean, just 2 kinds of force, 2 kinds of matter, 3 interactions. That's all it takes. Really simple, and it perfectly duplicates how you would model charges if you model charges with fake repulsion and attraction made by some other mechanism. This simple mechanism perfectly duplicates the function. So I just should point that out. That is something I would appreciate some physicists looking at and then saying it's garbage. I just like, instead of just ignoring it, I'd like them to actually say, oh yeah, that's garbage. Just to prove that they're the ones against science. That they're really not interested in the truth. Because frankly, it's going to win the Occam's razor explanation award. Okay, there's nobody's going to find a way of creating a physical mechanism that creates the phenomenon of charge with anything simpler. Not going to happen. All right, just in case this guy's still listening. Anyway, I'm willing to pay you for your time to answer my questions. That's all. I can make it all into just pointed questions and just say, could you answer the questions and such, and I'll pay you for your time to answer the questions, as long as it's reasonable. Alright, so I believe I'm ready to play the video. Okay, so I'm right in the middle somewhere he starts talking about charges, and he's going to talk about light and atoms. And so I'll just point out one of the things that just doesn't make much sense in the 2 things argued by physics in terms of what's happening.
Charges plus will repel each other, and 2 opposite charges will attract each other. And that's the nature of it. But what do we mean by charges, and why do they repel each other, and what's going on?
So he's not going to explain why they do that. And I can't explain. So, just saying.
Well, let's think about this concept, an incredibly important concept to all of physics, and in fact, incredibly important concept to the element of what we call electromagnetism, is the idea of an electric field.
Right, and it's just an idea of a field, okay? Instead of making it out of something that actually is coherent. So instead, they draw it like they know the positive and the negative are arbitrary, in the sense that the two charges are distinctly opposite, but one of them isn't sucking in and one of them isn't pushing out. But that's the only way they can illustrate it. But they know it's not doing that. I think they know that. You know, and so they're both radiating objects, and one of them radiates something different than what the other one's radiating, and that's the real point. But anyway, continuing.
An electric field.
I mean, there's no, the whole idea that one can excrete something forever and the other one can absorb something forever doesn't make much sense. The vacuum cleaner thing just doesn't work because it's got to have an outlet.
Field is the influence in space by an electric charge to everything around it. And it doesn't have a limit. It just...
See, when he uses the two positive charges, they're flowing out, right? So, yes, repulsion makes sense. But if he did that with the electrons where the arrows are pointing in, then they'd both be pointing in and want to pull each other right into each other. So it doesn't really work. It's really not a consistent theory or statement or description or explanation, because it has this huge flaw in it where, well, if you show the two electrons, you can't do this little, look, the forces are pushing on each other thing, because the two vacuum cleaners aren't going to push on each other. So it's just kind of cheating, right? You just do this one half of the argument, and that way you can say something happens or imply something happens that really isn't true. The two electrons are doing the same thing that the positives here are doing. Same exact thing. They're pushing on each other. They're pushing each other away. They are not sucking up space and connecting to each other.
Just keeps going. There's no limit. It just...
Okay, so another statement. So there's no limit. So you could argue that if we thought of these forces like the sunlight coming off of the sun, you could say, yeah, there's no limit to how far a photon can go, but there's certainly a limit to whether or not any photon will go some places. So eventually you get to a point where the photons are spreading in two dimensions. So they're getting further away from each other this way and this way. And there's places in the universe that you could figure out billions of light years away, perhaps, where there's gigantic hunks of the universe that'll never see a photon from the sun. It just ain't going to happen. Because the photons are so rare, the ones that can get that far. Especially you could argue the ones behind something else will never see a photon. So everything, wherever the moon is, okay, blocking, or the earth even, it's blocking, absorbing the sunlight. The sunlight is casting a shadow behind it, and those photons are never going to get to anywhere else. So there are limits to this field.
Its intensity drops off as the distance squared, but there's no real limit where it says, well, now I'm done, and it stops, and it's the end of the line. So really, this picture of an atom that is out there, or a plus charge that sits there, and that plus charge just has these what we call field lines. And if you
so it's lines of force versus field lines, and this is where everything gets messed up. So I would argue that magnets and atoms, I mean the electrons and the protons anyway, it's not about field lines, okay, it's about lines of force. And the ones that don't mean anything are the things that should be called field lines. They're the things that Faraday paid attention to. Where the iron filings line up is nothing to do with any kind of path that anything's moving. It just has to do what little magnets do. When you put a bunch of little magnets and you don't let them, you have some mechanism, some frictional mechanism that stops them from jumping right into the magnet, then this is where they'll line up because they're all repelling each other, and that's the arbitrariness of the lines. Every time you sprinkle the filings, every time you use filings of a different density, the lines will be in a different place. It's not any kind of consistent thing being created by the charges. It's being created by the things that are being affected differently by the charges. And the real lines of force are the idea of something radiating from the body. So that's I probably don't need to draw it. So a line of force would be this, the idea of actual straight line force excreted by the thing, and that those two things are excreting different force. And that's the way to understand it. The green thing is excreting a green force, the red thing is excreting a red force. And that way you can make it make a lot more sense. If you just say, well, the green force is inert to the red force and the red force is inert to the green force, then you can figure out pretty quick that, oh, they'll be attracted to each other because they're going to be pushed by the external universe into each other, because it is a push-averse. So yeah, I don't think I have to draw that. Huge difference, though, between a line of force, a straight line of representing the density of the particles flying out of something. So you could draw the same picture for the photons leaving the sun, the same exact idea, and you could say, well, it's the inverse square leg, same exact idea. You just measure how far apart they're getting over a distance, and that'll tell you, how many of these lines you intersect. And you could just measure how many photons you could get hit by, how much energy the sun is producing. So it works for anything that's spherical and produces energy consistently over that spherical surface. Everything will obey the inverse square law. So gravity is just this drawing in reverse, with the arrows going the other way. Oh, it's so obvious. I'm just like, oh, do I have to do this over and over again for the rest of my stinking, lousy, crappy life? Yes, I guess so. Oh, dang it. He has a bow tie, so I'll try to control my language. Seems appropriate.
Place something, say another plus charge, at a location on a field line. The total number or density of field lines at that location determines how much it's getting pushed away. So the field says, give me a test charge.
Yeah, so the more accurate you want your statement, the more lines you arbitrarily draw proportionally coming out of the object. So it's sort of like Newton's calculus. You're basically just saying, well, let's get a close enough answer. So you can go as deep or as shallow, as necessary. So I could draw 10 lines, I could draw 5 lines, I could draw 2 lines, and then I could just measure how close they are to a line and say that counts. It doesn't really matter. But if you wanted to get a really exacter, more precise answer, so the more lines you draw, the more precise your answer would be. If you were going to use this kind of graphical thing. Obviously, you can duplicate this mathematically.
I'll tell you what force I'm going to exert on another due to the charge at the source. So I placed a little test charge at the source of the at the field line, and we can place another test charge. Maybe one's plus, one's minus. But if it's plus, it gets pushed away, and if it's minus, it gets attracted towards it. So the field lines also determine the direction of motion that the test charge will go.
So they really don't, as illustrated by his own drawings. So that's not going to be true. But anyway, so they say it, but it's really not true. The field lines will say to you by their drawing of them, where the negative has lines going in and the positive has lines going out. Again, it's not going to tell you the truth when two electrons meet each other.
And from a plus charge, we can think of it as being outbound, and a minus charge, it can be considered inbound.
And that's just, considering it, that is just, okay, you're allowed to make up something, but you just made that up. Okay, and I would argue that you could know that it must be something different than that. because that just doesn't work. Again, it isn't consistent. So that doesn't really work. It's something else that's causing the phenomenon than vacuum particles and blower particles. There's not a, this isn't the two sides of the vacuum cleaner. It just ain't working that way.
By convention, it doesn't really matter what direction, but
so it does matter, but whatever. And the big difference, well, anyway, let's continue.
We can just do it that way. So a plus charge, if you place another plus charge on a field, in an electric field, next to a plus charge, and the test charge is very tiny, so incredibly tiny, or posited to be tiny, that it actually is the thing that's moved and not the source, because they're pushing against it. Remember, Newton's equal and opposite forces. One of them just has...
So, yeah, but what about kinetic energy and scalars and anyway.
Has to be a big enough charge that it doesn't get affected by the other charge as much. So the test charge can be infinitesimally small. And then it just...
So why would you do that, though? I mean, it doesn't, once you make it small, by comparison, it can't have enough effect on the movement of the other objects so you wouldn't care. It can't possibly make any difference. So if you're going to figure out a satellite and you're going to start worrying about how much the satellite moves the Earth, well, you don't have to worry much.
Just gets rocketed out on those field lines and it goes very, very far away. But if you place it closer, then the field lines are denser, and that means it gets a harder push. And if it's
so it just means more photons. If you were to think of it as just photons, that the body's radiating something, the radiation obviously is, it can push you, give you momentum. So obviously the closer you are to the surface, the more bullets, if they were bullets coming off the surface of Earth, the more bullets you'll get hit by, and the further away you are, the less bullets you'll get hit by. By the inverse square law. So it diminishes significantly.
If it's a negative charge, then it'll be attracted in the same way. It'll be attracted not as much if it's far, and the closer you put it, the more attraction it shall be.
Right, so we agree on that part, but everything else, no.
So it gains energy as they fall towards each other because they're pulling on each other, and the closer they are.
They're pulling on each other. So, no, there's no gaining energy in any other sense that, yes, they're moving towards each other because they're attracted. And that's not making a condition, that's not compressing a spring.
The harder they pull each other because the force of attraction is increased as they're...
So it's not really a force of attraction, it's a force of from the outside pushing in, and there's the absence of pushing on between them, and that's all you really have to have is something that degrades the force between them, shadow, and therefore they fall into the shadow. But it's not really a shadow.
Distance as their distance is made small, and the force of attraction or repulsion is decreased as they're farther and farther apart. And so at some point they can be so far apart that the electrostatic or electromagnetic force between them, the electrostatic force between them can be minuscule and not taken into account. However,
yes, and compared to their environment, so it's always there as stated, but the other things in the environment that are closer to it are going to affect it so much more that it would be a tiny, even less of an, if everything was dead still, then you could maybe notice an effect, but nothing's dead still, so everything gets diluted by all the other action. So it's sort of like a Tesla. I mean, Tesla was an interesting character, but I mean, the idea that you could put energy into the Earth and it would pop out somewhere else. But what Tesla wasn't considering is that there is so much activity, just from gravity and all the other crap, that there's no way to push more in one place and guarantee where it pops out. It's going to pop out almost anywhere. So you can't collect it because you already lost it as soon as you put it in. Because as soon as you put it in, it popped out somewhere else. The pressure equalized, and so you have no way of extracting any idea that you can push into the Earth and then collect what you pushed. It really was kind of a dopey idea, that whole tower thing.
If you have loose charges around there, they really the electric force is very strong and is going to really try to actually make it so that the charges get neutral.
So you could just argue it's a magnetic force. It just doesn't matter. You call it electric, you can call it magnetic, because it's exactly the same phenomenon in the sense of the attraction and repulsion of north and south. It's the same thing as plus and minus. It's doing exactly the same thing. You could say the electrons and protons are the electrical monopoles, and they're also the magnetic monopoles. They're what makes an atom have a magnetic character. And the difference is that polarity, okay, is the idea of it going, north south. But in an atom, especially one that has, say, 50 protons and only 30 electrons, obviously it can have polarity in different angles. It's not, up down. It's this way even. Red, red, blue, blue. North, north, south, south. And I would argue that this is how atoms are actually polarized. And guess what? That creates the thummy thing. Your right hand rule. Anyway, there's another subject, but continuing.
In any event, opposites attract, like charges repel. And if you've got one, you got the other. So that's really what we're talking about. So
Got one, you got the other. It's just a little simplistic. But obviously you need a mechanism, and you don't have one. To just say it's some electric field thing, again, it's not consistent the way it's drawn with these arrows, in the sense that if they were excreting these arrows and the other thing was having arrows pointing in, that doesn't work as a model. And you should just be upfront and honest about that is a little bit inconsistent. So it doesn't work. You have to come up with a better explanation than lines of force going into one object and lines of force coming out of the other one, because it ain't how it happens. And obviously the magnetic field lines are not motion. There's nothing moving on those field lines, because if there was, you could actually create stuff moving on the field lines, and you can't do that. That don't work. You can't put a magnet down and watch things go from north to south. It doesn't happen.
plus charges repel against plus charges, and minus charges repel against minus charges. Protons have a plus charge, electrons have a negative charge. They have exactly the same amount of charge.
So he says it doesn't matter about which one's negative and positive, but obviously it's a huge mattering thing, in the sense that Maxwell's equations are really turned a bit sideways if you reverse it, and you're supposed to, because of the fact that the electrons are the things that pile up and create charge on surfaces. The extraction of electrons and the addition of electrons is what increases and decreases the pressure of the force excreted by the object. And so clearly it would be much better if you called the proton the negative and the electron was the positive, because it's the adding and subtracting of those positive components that creates the differentials in larger objects.
They are just opposite and equal magnitude. The electron has a much smaller mass. The proton has a much larger mass than the.
Right. So the only thing, it's probably just something they do by accident, but they draw them the same size, and that idea, I think, is perfectly reasonable, in the sense that their profile in the universe has to be equal if they're going to be able to have an equal charge. But obviously the proton, whatever it's made out of, is more dense, and so protons don't move as easily as electrons do. That's why the protons are stuck in the nucleus and the electrons are both in the nucleus and in the exterior of the atom, is because the electrons are a lot easier to move. I think that's the simple explanation. Now, I don't have any proof for that one, but I'm just saying it seems plausible that would be the explanation, that although they have the same size, they have a different mass.
electron. So the proton tends to stay still where the electron tends to whiz about. All right. So distant charge.
So this whiz about part is part of the whole problem that's in this part of your explanation when you're going to start explaining how a photon functions, because you're going to say, you're going to talk about protons and electrons as if they're standing still in the atom when your theory says they're doing all kinds of moving. So they can't really do this while they're doing all this other stuff, because you never see this. Okay, doing this while you're moving all over the place would be unrecognizable. It's like if I, do this with my hand, but then my hand moves all over the place, you're not going to see this part anymore.
Charges feel the effect of other charges. So all charges feel the effect of the other charges through the electric field that they generate.
So you could argue that, yes, objects can see other objects, and you could argue that if it was, a lot of protons here, and there was a few electrons here and protons here, and, that they could see that pattern, okay? And it's really just about the pattern of the profile of the object. So you have an atom with electrons and protons in different positions, creates a pattern, and the other objects can see the pattern. And if they can match the pattern, then they're going to move to match it. They're going to be twisted and turned to match it, just like a magnet moves to match the magnetic field it's seeing the other object radiate. So this gets to there's a whole bunch of subjects here, and one of them would be is that none of these things are excreting anything from any internal engine. They're just taking in the external world and reflecting it. And the fact is, they reflect it different than how it came in. So energy goes into a magnet, one way, and it comes out another way. Comes out Vulcan. So it's excreted different, segregated, changed, filtered. That would be a good word. The force is filtered by a magnet, not created by a magnet. So a magnet isn't radiating anything. It's radiating the same stuff you're radiating. It's just made the colors very different than the colors you excrete. The radiation you're excreting is different than the radiation the magnet is excreting, in the sense that the frequencies are different, but it's the same elemental stuff. It's just that it's not in the same category of pattern. It's a different pattern. Yeah, that's the short answer. All right, continuing.
So really, space is permeated by the electric field due to charges.
Right, so I would say space is permeated. It's full of cell phones and all kinds of energy from all kinds of things. This photons bouncing off of things, and some of the photons aren't visible. We already know that. And some of them are even more invisible in the sense that they don't have a frequency. So we can't see all these other frequencies of photons that we're being bombarded with constantly. And what if there's no frequency at all? Okay. And I'd say that was gravity. So it's all one field of charged energy moving the speed of light. And the charge would just be, in my opinion, the obvious answer I have falling apart, is that there's two discrete types of force, just like there's two discrete types of material object, electron and proton. Neutrons are just made out of electron and proton. It's all so simple, and I'm sorry, the story you're telling is way more complicated than it needs to be.
And if they're all standing still, all these electric fields...
So if they're all standing still, so the Bohr model has everything globbing all over. There's all kinds of movement. So, and then you do your quantum mechanical crap where you say it's not even in a position. How can it radiate a signal to something else? How can something else see it if it's not even in a position? So again, it breaks the whole idea that these are radiating bodies and that they have a visibility, that the other electrons and protons are doing the same thing we're doing. They're looking at each other. They're watching each other create patterns in the field. And how can they do that if they're superpositioned? It would be impossible for them to do that if they're not in one single place at one single moment of time. So besides the fact that you have them moving, which is not brilliant in my opinion, okay, electrons doing figure eights is not a brilliant idea. And the idea that they are magnetic, and that is they're stuck in magnetic positions. An electron's locked by the fact that there's an electron over here, an electron over here, and there's a proton here, and it's attracted to the proton, but to get to the proton it has to defeat the two electrons guarding it, kind of idea. Magnetic model works. Their electrons and protons are stuck in positions and they are unsettled in those positions, so they wobble a bit, but that's it, a little bit of wobble.
Don't move. They're just kind of sitting there. If everybody's held in place, they're all pinned down. Let's say all the charges in the universe are pinned to one place, to wherever they're at.
So why would you say that when you know that's not what your own theory says they are? They're all over the place. There's one flying to Venus right now, and then it's somehow going to superposition, and it's going to get de-entangled, and all of a sudden it's going to show up, in this cup. So even though it was heading for Venus, it's going to show up in this cup. I mean, sorry to mock it, but I mean, it really is. It's silly.
No matter where they're at, they're just pinned. Then everything would be pushing on it, but then they're pinned down, so they can't move, but they're pushing with the electric field, or they're pulling, depending on their charge.
So they're not pulling. Okay, so there's just an absence of push. Again, it's a push-averse. There are no pulls. Pulls is magic. So the physical universe can only push. It can only, something can blow on something else, but it can't suck on something else. If that's a way to analogy, that's not even a good analogy, right? Because, yeah, you can create either motion. But the fact is it either radiates like sunlight. It either radiates light or it doesn't. There's no opposite to radiating light. There's no unradiating.
Charges, or the signs of their charges, and that tells us how they're going to move. All right. Now let's do something very strange. We then jiggle one of them.
So, okay, so this is the part where, I'm saying, so you're just saying this is completely inconsistent with all the other crap you teach. So you teach that this electron doesn't have a position, that if it does have a position, it's moving, 400,000 meters per second, moving around. Maybe it's in a complex compound and it's moving all over it's in this atom, then it's over here, then it's over here, and it's over here. It's moving all over the place. It's being shared and moving all over. No. I'm just saying, how can it do this and anybody see it? Come on, it's impossible. It can't be orbiting and then going, oh, I'm going to make a little jiggle, and he's going to see it over there. That ain't going to happen. No chance.
If we jiggle them, then the field must change.
Right. So the important thing to say is that they're in positions, and we know there's a whole bunch of them on the outside of a surface. So the surface has electrons on it, not protons, electrons. Okay, it can have fewer electrons, but it always has some electrons. And so if you understood that electrons can do this, or they can do this, they can do this, or they can do this, that would be the motion that matters. And what is this and this doing? Well, that's not doing this, and you see that. You see me going up and down. No, it would be more important if I'm doing this. If I'm moving towards you, then you can understand how I'm collecting all of the light, or all the force, and I'm bringing it, to you sooner. Okay, I'm taking a bunch of stuff that was in this much space, and now I'm reflecting it in this much space. And so that's what's happening when electrons move this way. And when they move this way, what's happening? Well, they're doing the opposite thing to the field. They're taking energy that was in this much space, and now they're putting all of those little dots in this much space. The reflection is now going to reduce the density of the particles, the bullets, and doing this increases the density of the bullets. That explanation is a lot better, and it completely fits with the idea of frequencies of compression. So the idea that, a blue photon could come in, okay, with a tight compression, electron could move back, and now what's going to happen to that blue light is it's going to be turned into red light from the point of view of where it's going to get reflected from. It's going to be expanded, and vice versa. Red light coming in, electron pushes on it, okay, and now it's blue light. Something like that. Obviously, there's restrictions to the easy conversion of one electron doing all the work, which it doesn't do. So the very idea that two electrons that are so infinitesimally small, I can't even describe how small they are, they're so small, seeing each other at this distance would be impossible. So you can understand how the atoms could see each other, but the electrons, yeah, no chance.
And how does the field change? The field may change in a regular way. Let's say you instead somehow take an electron and put it between, let's say you staple it between two springs. And if it's between two springs, it might go up and down between the two springs, or it's stapled to between two boards on two springs, and so it can go up and down.
Yeah, I know. So this is what they're creating as a field, that somehow this electric field is stapling electrons with springs all over the place. So, I mean, they're not taking any responsibility for this motion, requiring there to be springs or some other kind of field thing that's making it do this weird crap. And it's just, there's no infrastructure imaginable for that. When the simple explanation is you could shoot bullets, one bullet, then a second later another bullet, and a second later another bullet. The bullets fly through space. They have a frequency. They have a period between them. They arrive at a surface, so it fits. Imagining a radio wave being 10 miles long, like it's some sort of thing doing this, and it's 10 miles long, when the simple explanation is no, there's a compression in the field, and 10 miles at the speed of light, there's one over here, and that's the distance, that's the frequency. And I can make that as small as I want, or I can make that as big as I want, and it doesn't create any continuity issues. I'm not expanding and contracting a particle. I'm just expanding and contracting an event when they happen. So something really simple, just changing the time between the events. Okay, that's really easy to change. Or this idea that you're going to change some object. Yeah, no chance. The simple explanation should win. That's what the rule should be. At least I say so. Alright, continuing.
And as long as you don't touch it, it's not going to vibrate, just like anything that's held by two strings between two boards, right? But if you come along and flick it, then the electron will bounce up and down, right? Now, if the electron has an electric field,
so I would argue that it's already doing a ton of jiggling, and the point is you can make it, you can hit it, and then it moves, from one position to another position, in its locking relationship to the nucleus. So the electrons have a relationship to protons and electrons in the nucleus. So the nucleus has the electrons in it. That's what the neutrons are doing. It's providing the electron. So there's twice as many protons as there are electrons in the nucleus because of the protons. So it's net positive, but it's not entirely positive. And that's what keeps the electrons from just crashing into the positive nucleus, is the fact that there's no clear path to get to the positives in the nucleus, because there's always electrons guarding the protons, so to speak. There's always a component of negative force that they have to overcome to be able to, repelling force. So just as if I had a south side magnet, then a north side magnet, then a south side magnet, you can understand that a south side magnet can't get to this north unless it can overcome the repulsion from the other two souths. So again, a magnetic model works so much better than this electrical model. But no one will pay attention to that argument.
That's associated with it, and the electric field is inbound by convention, and the field lines are drawing towards it. So let's use a proton, so it's outbound. I like the outbound arrows.
So outbound arrow. So again, they're back to these arrow things that don't have anything to do with the actual function. The electron and the proton are both outbounding. They're both reflecting the universe. The electron is reflecting blue. The proton is reflecting red. That's the difference.
So a proton is staying put, and it's held between these two springs, between the two boards, and you kick it. Now it's going up and down. And if it's just going up and down,
Ooh.
bouncing up and down like the...
Yes, that is fun.
What do we notice? The field...
So again, so what do we notice right now? So the only way this little bit of jiggling up and down could mean something to something over here, how does it know that up is this way, okay, and down is this? How does this cause this to move? You can sort of understand that this, okay, that can be moved into something because it's pushing, but this is not going to cause, this isn't going to cause this to go up and then this to go down. That ain't going to happen.
Doesn't stay fixed in space. The field follows the proton. So the proton was here and the field radiates out from wherever the proton is at that moment.
Just understand that, yes, the push thing you can understand. You're pushed on something, even if it was an ether you believed in. You're pushed on the ether pushes the other object. I mean, that you can understand. This? No. Bad model.
Moment. So then the way, some of the field lines aren't fixed in space. They're moving. They have to be moving up and down.
Okay, so again, and this is in a model where they've already conceded the electron is moving 400,000 meters per second. So how does it do this? It's not even doing, it's not going to create this because it's already moving. So it can't create that. It has to create something, some other weird pattern. And what happens with, if it's going around a proton, how can jiggling here do it any good? It's not going to be able to, send a signal when the signal can't even get through the proton. So come on, it's a terrible model. This is not something you teach as if you figured it all out and you have this great answer. This is not a great answer. You should sell it for what it is, a lemon. Okay, you should at least concede, look, we never drove this car, we never tried to start it, we've never done anything, it's never driven a mile down a real road in its life. Okay, tell the truth selling this thing. Because frankly, in my opinion, it has no engine, it has no steering wheel, it's not even a car.
Wait a second, if you make something move up and down, then you've got a wave. Now what happens to that? Well,
right, and if I did that, okay, I mean, you got a wave on a surface, you can say, okay, that's going to cause something to go up and down. But that's not, that analogy doesn't fit with light coming off of a sun and somehow making the other object move up and down because the sunlight is not hitting it. Why would that move it up and down? No. Bad answer.
Well, then there's a disturbance or a wave motion of up and
a pattern. But the pattern is compression and rarefication, or whatever the word they use for an expansion. It's compression, contraction, expansion. Contraction, expansion. That's what's being sent from one place to another. That's what my shirt's doing right now. The little blue bits is vibrating more than the red bits. Higher frequency of vibration.
And down of the proton, so now the electric field is going up and down. Now,
so my shirt isn't doing this. It's not what my shirt is doing. My shirt is doing this.
How long does it take for something very far away, a distant charge, to feel it? Well, those changes in the electric field propagate at a particular speed.
Right, the speed of force. All the little discrete force moves the same speed. Gravity, magnetism, electricity, all the same speed. So it really should be called the speed of force. It shouldn't be called the speed of light, because then you're stuck saying stupid things like, well, the magnetism is moving the speed of light. Well, no, it's moving the speed of magnetism. Okay, so come on, be fair. It's moving the same speed. They're all components of force in its rawest form. Okay, in the only form we probably should talk about it in. Force should always mean the discrete stuff moving the speed of light in vacuum. And that's how it should be understood. But unfortunately, they go with this explanation instead. Speed of light. Everything's moving the speed of light. So light is somehow special, when the whole point is, if you know the physics, now there's nothing special about visible light.
The speed of light. So really, what is light? Light is a disturbance in the electric field.
No, light is a component made of components at a frequency. A photon is an event. It hits a surface, bang, 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 with a frequency, and then that frequency has a polarization over the surface of the atoms. So I could argue that it's sort of proven. There's transitions. I've explained in different videos how, yes, there's a distinct line that's drawn between microwaves and, say, infrared photons, in the sense that they're made, one of them's made by the radio style waves. Frequency is made by a compression, okay, of a bunch of little bits, and they're not really photons, they're bits of energy, and they hit the surface, okay, with a frequency, and that's a bit different than what a photon is. But anyway, the idea of what happens to an antenna, it kind of gives the story away. The electricity goes up the antenna at a rate. It's got to take a charge differential you're putting in, so you're putting in this alternating charge differential. The differential has to actually move close to the speed of light through the antenna, and that's where it's doing this event, and that's what's creating the polarization. So the antenna is making the polarization of the compression. So the compression's coming off the antenna, as clumps of pressure. Well, it's actually this way. This one came out first. This one came out next. This one came out next. So an electron went like this. Then the next electron went like this. And the next electron went like this. And so you've compressed the field, and you have that compression moving at the frequency you're pumping the electricity in it. So the alternation of the electricity is dictating the stripe of compression that's leaving the antenna. And for light, it's about just individual atoms. So it's the size of the atoms that decide the polarization. So the polarization is dictated by the size of the atom, and the polarization is really what's defining blue and red in a sense of being detectable. It has to be the right frequency, but it also has to be the right polarization.
Of a charged particle that makes a
See, now that is not going to affect another proton or electron. Shooting light in straight lines from different places is not going to cause something to move up and down. It's not going to work. Pushing, that'll work. Push-a-verse Push-a-verse. Push-a-verse. All right. Continuing.
Disturbance, it vibrates, it moves, it accelerates, it changes. And as it changes, the electric field...
So I'd say that's just a nonsense animation. It really doesn't work that way. No. Just wrong. I don't think it's a very good explanation. It's not very mechanically coherent.
Disturbs, and that disturbance propagates along. That disturbance is called a photon.
So I would argue that that's not much of an explanation. So first we have the whole idea of the frequency. So this big giant thing is one frequency. How does it measure one frequency? You know, one sample. So that doesn't sound very logical. And the idea that one electron would receive one photon, again, doesn't seem very logical, because then photons would be even smaller, right? I mean, they'd be so tiny if they were communicating from electron to electron. There obviously something has to hit a surface, and it has to affect more than one atom. That's what it's doing. That's how it creates the electricity. The electricity is causing a change in atoms. It's atoms being affected in a sequence. That's electric current. And when you're hitting something with that, you're not going to be able to create a current. You have to be able to push it in through more than one atom. So it has to be, it has to be pushing on more than one atom to create the electricity. Seems inescapable, just as the electricity has to go through more than one atom to create a photon.
That's light. Light is that disturbance. Now,
so you're saying it is, as if you proved it or you demonstrate or you have some evidence, when it's just a made-up model. And in my opinion, it's a really crappy made-up model, because it really doesn't show anything here about this idea of what a photon is. So Einstein did a pretty poor job when he did his photoelectric. I mean, he wrote very short papers. Okay, he was an amateur. But you would think he was it was early Einstein, so he didn't know he was going to get published, didn't know he was going to get famous, any of that stuff. But it's a pretty thin paper in terms of, you're saying, gee, these are the, he should have, he revised, he spent so much time talking more about relativity, and he never revised with a nice big paper or book about what a photon is. And so you have this, kind of missing bit of, some sort of real explanation for, saying light quanta. Does he mean that the photon is made out of quanta, or does it mean one quanta is a photon? So that's a problem. Because if you go back to the one quanta thing, then you have to go back to this idea that somehow there's a 10-mile long quanta, and then there's a gamma ray is some kind of infinitesimally small quanta. I mean, that doesn't work. But frequency of events does work. And you can't really detect a frequency without the two events. At least two. I'd say it's more like 3 or 4, but whatever. It's at least 2. At least.
Why doesn't it propagate forever, like these vibrating strings that we see, or like you can pluck a string and have a standing wave? Well, photons propagate from here to there in the same way that if you take a jump rope and you flick the jump rope, when you flick the jump rope, it bounces. And if the jump...
So none of this has anything to do with their theory, because their theory is the photon is a spreading wave, and it's all going in all directions. All right, and it's not until you de-entangle it or whatever, you decide that it has to hit something, whatever it hits first or whatever, it becomes one discrete photon there. So this isn't consistent with that. So they argue for these different mechanisms, and yet the two mechanisms aren't consistent at all. This is a laser beam, and he's just saying, look, the laser beam wobbles a little bit, but it's a laser beam. It's not a wave. The whole idea of the wave is that it comes out and it spreads in all directions. So where is that part of the photon in here. When it's going to the 2 slit, we're supposed to believe that the photon doesn't have a position, you know. How come these photons do?
Rope bounces, then you see the pulse go down the jump rope and the pulse comes back from the jump rope. Now you can make it so there's a nice regular pattern to it. You can do double Dutch by having 2.
Oh, that was a terrible drawing because the waves were all different sizes. That doesn't happen, blah, 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 blah. Anyway, the wave coming back, I guess, was supposed to make a double peak or something, blah, blah, blah. Anyway, photons aren't doing any of that. It's definitely a one-way trip.
The jump ropes go around. You can make it have a nice even string where you have wave patterns in the rope. But really, if you flick the rope, then...
No wave packets, whatever. You know, not a really exact kind of statement, this wave packet thingy.
The disturbance goes down the rope and back the rope.
So I don't know why he's getting into this back and forth thing, like the photon is somehow dependent on a reflection and it's a, you know, it's going back and forth at the speed of light. No, that's not happening. So I don't know exactly why that's in here, because that's really coherent to nothing I ever heard as a physics theory.
And that disturbance in the electric field line, as it propagates due to the previous motion of the proton, is what...
So, and again, he's saying it's the motion of a proton when clearly all of the electromagnetic spectrum is about what electrons are doing, and it doesn't have anything to do with what protons are doing.
What the photon is. It's a disturbance in that electromagnetic field. That's really something. So a photon is a disturbance.
So this is what he's saying. So a photon is a wave packet in the electric field. So it started vibrating slowly, and no, it doesn't make any sense. He's basically saying now a photon is going both ways. It can't do that at the speed of light. It doesn't have enough time to do 2 trips. So it can't be any kind of standing wave thing. Oh, I think that's just terrible explanation, frankly. I've seen some bad ones, but this is bad. That's not a wave packet. The wave packet would have to be a certain number of your little hunks of frequency jiggling. you know, but doing this, yeah, no way. It doesn't, it's, you know, well, continuing.
Disturbed magnetic field that was disturbed, say, some time ago by a very distant thing, and then that distant thing, that propagation.
So there's a pattern sent. Everything is reflecting patterns. There's patterns all over me. I'm all kinds of patterns. And that's all. There's just patterns. And the pattern is just pushing.
Of that electric field from there to here gets to us eventually. Isn't that weird? If that's what light is.
So now he says if. Yeah, so now he throws the if in there.
If that's what light is, and that's probably a very...
All right, oscillating electromagnetic field. So then this is the part where they make up this little, you know, and he draws it as if the 2 fields are equal, and the whole point is obviously one of them is 90 times more powerful than the other one, and blah, 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 blah. But there's no, you know, you can induce magnetism, you know, by moving the electrons and protons. So that's all you're doing. You're just sending a signal, and there's not a magnetic component and an electric component. There's just one field, and you're just pushing on that one field and sending a message. And yeah, there's just no role to play for the proton in the phenomenon of photons. It's really just about electrons. It's electron force on electron force.
A close analogy to what we call it from deep studies of what the nature of space and time are.
Deep studies, blah blah blah. So space and time, again, I could have, you know, there's lots of arguments that there's no such thing as a bent space because of the energy conservation problems. You can't heat everything in the universe for free. You have to use heat to heat. You have to use momentum to heat. You can't use bent space because you can't put the momentum back into the bent space. There's no place momentum dies and turns into bent space.
Then light, when you look at some distant galaxy, maybe millions of light years away, there was some electron that shook, just a tiny electron or a tiny proton.
All right, so I'm going to argue again that it's okay. It's still tiny. It's just a little bit of motion between electrons of an atom, and yes, so technically a part of the photon is made out of one single electron contributing its contribution. You know, one atom pushes an electron out, the next atom pushes an electron out. That's the mechanism, and it is just showing how the universe just doesn't have any fudge in it, because yeah, the thing can travel these insane distances, but clearly we do see that the wavelengths change, the frequency changes, so something happens to that photon as it's traveling, I would argue. All right, and it's not it's not blue shift and red shift. It's not some Doppler effect. It's the fact that the photon has to travel through space, and it's going to hit a few electrons and protons on its way. It's going to hit a few hydrogen atoms, and every time it does hit one, its frequency is going to be enlarged a little bit.
Very, very, very lightweight object shook, created a disturbance by its shaking that made a disturbance in its electric field, and that electric field...
So it's not its electric field. There's only one field around everything. So again, it's just this pattern. If I'm in empty space and there's nothing to block it, the pattern keeps just flying through space. It just keeps doing it. And the fact is the pattern is so dense. I mean, it's coming off at all angles. I can turn and you can still see it. So no matter where I am, the light is bouncing in all directions. So it's sending an image to everyone. All right. And all of those images, until they're absorbed by matter, are perfectly durable.
Disturbance propagated out through space on the electric field of the proton, and eventually reached your eye 3 million light years.
So of the proton, he said again. So I don't know why he's using protons causing an effect in an electron. I just think that's totally wrong. Electrons can't see protons. It's that simple. They really can't see them. All they can see is the deficit in the electron field. The proton shadows, okay, the electron field, and that's all that the electron can see of the proton, because its force is completely inert to it. So I don't know why he's doing this. Due to a moving charge, the disturbance travels through space as a wave. So obviously it doesn't, in my opinion. It just travels through space as a frequency of events, eventually interacting with distance charged particles. So yeah, I just don't know why he has a positive charge affecting a negative charge. It don't work that way.
Years away? Wow, that's interesting. So it propagates through space radiatively, carrying the energy of the disturbance.
Right, it's radiantly, like every other kind of radiation. Okay, so just like a radioactive isotope shooting protons and electrons, the electrons and protons are shooting the force in the sense that they're reflecting it.
That created it across space, vast areas of space, as a packet of a disturbance, as a wave packet,
as a pattern in a field of energy, little bits moving the speed of light. So little bits are moving the speed of light, and you can change their frequency, their compression, their density in space by doing things to surfaces. And in the case of radio, it's sending a bunch of little bits at any frequency you choose, except the high frequencies, of course. And then in the case of photons, particular visible photons and, well, photons, I guess. See, radio really shouldn't go big photons because it's a little bit different. You know, it really is a physically different thing landing on the surface.
The wave packet in the electric field lines as it propagates through space. That's an interesting picture of a photon.
It's like radio is a bunch of infrared, okay, in hunks of density. So you can understand, like, it's a bunch of little infrared photons in density. It's really just magnetism, but whatever. We can't, let's not make this more complicated than we have to. Induction is what it really is.
Photon, and that's what we call that. So that packet of waves, that disturbance, is called a photon. And electrons don't vibrate forever. Protons don't vibrate forever.
So again, I don't know why he says it has something to do with a proton vibrating. I've never seen somebody say that before, that somehow it's a proton vibrating and it's causing an electron to vibrate. Never heard that.
They take a certain amount of time and then they stop vibrating, and when it's done vibrating, then guess what? That's the end of the wave packet train, and there it goes. The photon's on its way.
So it doesn't, it's complete non-continuity with the Bohr model, complete non-continuity with the superposition, doesn't know where the electron is model. So none of that fits with any kind of notion that the electron is in such a standard position that it can do a consistent waving, when of course it's supposed to be bouncing all over hyperspace. You can't have both hyperspace and then an electron jiggling. You can't have those two things. That's called the contradiction. It's a logical fault. You're not allowed to do that and be logical.
All right. Now, that's essentially a very meat and potatoes sort of elementary way of talking about photons.
And it wasn't very elementary, it wasn't very fundamental, and it wasn't very evidence-based. That's the other part missing.
Photons have a certain amount of energy. That amount of energy is related to the...
So this is what they say, okay? This is their understanding, when I would argue that they don't have any extra energy. A blue photon doesn't have more energy. It's delivering it over a smaller period of time. So just like the speeding bullet does more damage to physical matter than the recoiling gun, because it's imposing the force faster than the matter can absorb it, and that matters. It matters how the surface area matters, and the speed matters. How fast you hit something matters, and that's all there is here. So there is no real increase in the energy. The amount of quanta is the same for the blue light and the red light, and all you've changed is you've compressed the blue light. So it can do more work quicker. No, more work was the wrong thing to say. It can do the same work quicker. It imposes the same momentum, but it imposes it faster than the colder light. And it's just about the fact that fast matters. All material things can be affected by the speed of the interaction. If the interaction is very fast, it can't adjust to it. So you could imagine an electron in an atom. And if it gets hit by a force that moves it a little bit slow, well, then it has a chance of coming back. But if it gets hit with something moving fast, the rebounding force will be too slow. And so it'll move too far away, and now it's broken. Now it's going to leave the atom, because you've created too much velocity too quickly. So it's a tipping point argument. Okay? The blue light keeps hitting something while it's still moving in the direction. And the red light, unfortunately, hits something and it's already slowed down or stopped or is now going the opposite direction. And that's why the red frequency won't tip it over. The blue frequency is fast enough to keep adding energy. the red light's too slow to keep adding. It keeps hitting it when it's not moving fast enough in the direction it's pushing.
Frequency or the wavelength, whichever you like to use, in order to...
So the period, okay, so all the words that have something to do with bullets rather than waves, they don't like to use.
Say how much energy the photon has. So the wavelength of the photon.
So wavelength is just it's just vocabulary making the cheat argument. God particle. I mean, it's just using language to distort the truth. There's no wavelength, okay, in any other sense that it's a distance, the distance between two things in space. That's the wavelength, and just should be called the period length. It shouldn't be called the wavelength, because bullets can be fired and they'll have a wavelength, but they're not waving.
Determines its energy. The short wavelength photons have high energy, the long wavelength photons have low energy.
So it's just not true. The bits, the quanta, the force bits have the same energy. Obviously you could have, lots of blue light, and so that would have more energy than a photon of red if it's more bits of energy. But just contracting the bits, just making the bits, instead of these, 3 dots, dot, 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 and just making it dot, 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 that doesn't make more energy. But it does make something more capable of screwing up an electron.
Energy. Radio light has long wavelengths, so it's low energy. Gamma ray light has short wavelengths, so it has high energy.
So again, it's just a breaking of the concept of what energy is, and the sense that what should really be understood is energy in the context of something's capacity to absorb it. And it's always a fair point to make, that it's not just about the total momentum that something has. It's about how much surface you spread it over, and it's about how much time you give the other object to absorb it.
Next, because it's a wave motion, and if you do something really interesting, if you take, because we learned this through electromagnetism, if you go take an electrostatics class, you learn about Faraday's law, you learn about the nature of the Biot-Savart law, you learn all these interesting things where if you take a current of electrons, which is now an electric flow, a flow of charges.
So it's really just not true. It's just the way they understand it. So the thing really isn't flowing. It's always a pointed force. And as I pointed out, sort of, if, the polarity of atoms in a magnet are not north-south, but, this way and this way, then you can understand that when they're arranged this way, okay, going up, and then they're the opposite going down, you could understand that something could be moving because it hits this, moves this way, with a component in this direction, and it moves right into the next one that's also a component in this direction. So you can get the idea that, it gets pushed because it sees that. It doesn't see this, So that's why things move around a magnetic field, is because the magnetic field isn't made out of bar magnets. It's made out of atomic magnets, which have poles, more than one pole, at angles. Right-hand rule.
In a circle, make a circular charge flow, you create a magnetic field.
All right, so that gives us, we won't get into all that. It's just another pattern. That's all you can create is patterns. So the reason why you can't transmit DC is because when you're pushing on the wire, you're pushing the electrons, okay? So clearly, and once you've pushed them, they're in a position you can't push them anymore. You can't push them twice. So you push them once, they move, and now they're stuck there until you collapse the field. So you have to keep collapsing it so you can push them. You can't push them until they collapse. So you have to break it to make it continue to move. It won't continue moving because once you've pushed it, it's pushed. Can't push it more. Simple things like that. All right, anyway, so we'll call it enough of a video. We'll see if we get any response. Like I said, these traditionalists, they're really caught up in their catechism, their religious, education, and they're not very receptive to being challenged to defend their theory of reality. All right, but they will spit on other ones' theories, but they won't defend their own. But I can hope. So that's what I'll do. I'll send a video and see if I can get a rational, reasonable response that I'm willing to pay for. Again, I'm willing to pay you to answer simple questions about what really moves a spaceship in space. Momentum or kinetic energy? Not a complicated question, really. But the answer is rather decisive, because the truth is momentum works. Kinetic energy is a fable. 1/2 mv squared is a fable. All right. Till next time and such, and so forth and whatnot.